How to straighten a curved graph. Remember the different types of graphs from last day? Linear, where y is directly proportional to x. Power, also known as a quadratic, which looks like a soft check mark. Root, which has a path like a ball tossed up left to right, also called a sideways parabola. Inverse power, which looks like a ski hill. And inverse, which looks a lot like inverse power since they're related. Here's some data showing how often a spring oscillates or bounces when a weight of different mass is attached to the spring and released. This is what the data is showing. As the spring is released, it will drop down, then return back to the top. This is called one cycle. Looking at the data, it seems to me that time depends on the mass hung onto the spring. The independent variable x is the mass, while the dependent variable y is the time. Time depends on the mass. As you can see from the table, it is obvious that the heavier the mass, the longer one cycle takes. If you would like to practice your graphing technique, pause the video now. Using Excel, I have graphed the data as shown. Note how it does not create a perfect curve. Unlike math class, where we provide you with an equation and you plug and chug numbers giving you exact values, in science class, we give you imperfect data, which may be affected by variables like wind or bumps in the ground, and you are asked to provide a formula for the graph as though the points were perfect. My line of best fit would be more like this. Notice that as the weight increases, the time also increases, but not at the same rate. For example, with a mass of 0.1 kilogram, a cycle takes about 0.68 seconds. With a mass of 0.2 kilograms, the cycle takes 0.92 seconds, not 1.3 seconds, which it would be if it were linear. Your homework asks for the slope of the line, which doesn't make any sense because it's a curved graph. What we can do is straighten the curve by manipulating the equation into the form of y equals mx plus b. Here's the confusing part, so pay attention and replay this section as needed. Remember, the equation for a radical function is y equals a square root x plus b, and the equation for a linear function is y equals mx plus b. If you put these side by side, you can see how the linear function y equals mx plus b looks so much like the radical function y equals a square root x plus b. The sole difference being the root x. If we exchange the x variable from the y equals mx plus b equation with the square root x variable from the y equals a square root x plus b equation, then we have a linear function. I know, confusing, so watch this section over one more time. The bottom line is if we want to straighten this graph, we need to change the plotted x values to root x while keeping our y values. That is, we need to square root the mass and keep our times. We'll always try to keep our y values the same and manipulate our x values when we straighten graphs. Here is our original set of values. We will make a new column for our manipulated x values. Now we need to calculate our roots. Square root 0 would make 0. Square root 0.10 would make 0.32. Square root 0.20 calculates to 0.45. 0.3 becomes 0.55. 0.4 is 0.63. 0.5 is 0.71. And root 0.60 is 0.78. This is our new data set. This is what we'll graph, and hopefully it will graph into a straight line. This is the Excel graph of our new data. Here is the line of best fit. As you can see, we successfully straightened this graph. There was a small chance that this may have been a cubed root or greater, which means that we would have had to repeat the process again and again until the curve changed from a sideways parabola to a straight one. This process of straightening can be done for many curved lines. Recall from our first lesson. This is a root curve. If you see a curve like this, to straighten it, plot y values versus the square root of x. If it's still curved, then plot the y values versus cubed root x, and so on and so on. The power curve, to straighten this one, plot y values versus x squared values. If it's still curved, try y values versus x cubed values, and so on and so on. Inverse, to straighten, plot y values versus 1 over x values. And if it's inverse square, plot y values versus 1 over x squared. If it's still curved, plot y values versus 1 over x cubed values, and so on and so on. Our next lesson will show you how these new linear graphs may be of use to you.